Okay, we'll pick back up with number 7 here, and so now we're going to have a quotient rule. So low d high minus high d low over the square of what's below. So go ahead and write that out. So low derivative of high minus high derivative of low over the square of what's below. Let's go ahead and start simplifying that. So we bring down x. What is the derivative of the natural log of x? Just 1 over x. Good. Carry down my natural log of x, and now what is the derivative of x? Just 1, and then of course the denominator is just over x squared. This actually simplifies fairly nicely, so what about this? Just gives us a 1 minus the natural log of x over x squared. Okay, this one I've just worked in advance because it's similar to the one we have a minute ago using the properties. So we have two terms here, so what are we going to have to do here? We can see we have product rule here, and then we just have it a term out by itself over here. So for the first one, you're going to have first times derivative of second plus second times derivative of the first. That's for these two. Then we just have the derivative of that term on the right. Okay, so we have, carry this down, what's the derivative of the natural log of x? Just 1 over x. Plus, bring this down, the derivative of this simplifies to x squared, and the derivative of this last term on the right simplifies to 1/3 x squared. And then from that point on, you're just going to be simplifying this out algebraically, and so it finishes with x squared natural log of x. So you can have multiple things going on in a problem. Just take your time and work through your steps. Okay, so what if we have the natural log times the natural log of x? Then y prime is going to be 1 over the natural log of x times the derivative of this inside, which is times the derivative of the natural log of x. Okay, when I simplify, first of all, I just bring this down. Now, what is the derivative of the natural log of x? Just 1 over x. So this is just going to simplify to 1 over, I'll bring the x in front, x times the natural log of x. Okay, our next one, let's do another one with the trig function. So y is equal to the natural log of sine of theta. So pause it and try this one. Okay, good. So check your answer here. Also, if we wanted to simplify this a little bit further, the equivalent to that is cotangent theta. So check your work. Okay, y is equal to the natural log of secant theta plus tangent theta. So let's take our time as we work through this. So y prime is going to be 1 over our parenthesis, secant theta plus tangent theta, d theta of that parenthesis. Okay, so let's just continue to simplify this. So first of all, I'm going to bring this down. 1 over secant theta plus tangent theta. This is just carrying that down. Now let's work on the derivative over here. What is the derivative of secant theta? I'm going to do this one in red. The derivative of secant theta is secant theta tangent theta, right? Okay, then I'm going to have plus, what's the derivative of tangent theta? Secant squared theta. Good. So basically we just want to be able to simplify that. I'm going to rewrite this numerator, factoring out a secant theta. So if in this numerator, if I take a secant theta out of this, what do we have left? Tangent theta. And if I factor out a secant theta out of this one, we have secant theta. And then over my numerator, which is in blue up there, I'm going to just carry it down. And now what do you see? Yes, a secant theta, tangent theta cancel, and we're just left with y prime is equal to secant theta. Okay, so find the first derivative. Our f of x is given, and you can see that this is just not very pretty looking from the very beginning. So let's use some of our properties of natural logs that we discussed in the beginning and see if we can simplify this a little bit before we actually start taking the derivative. So the first thing I'm going to do is let's rewrite this with the 1/2 power. Okay, so we rewrite that to the 1/2 power. The next thing we want to do is take these powers and move them to the front. Actually, we're going to rewrite this. Since it's multiplication, what can we rewrite it as? Addition, and then we can also pull powers out. So first of all, if I have natural log of 6x minus 1, if I pulled this 1/2 power right here to the front, that would just give me let me not do too many steps at once. So plus the natural log of 4x plus 5 to the third power. So because this is multiplication, I can rewrite using addition, using our property. And now I will take these powers, move them to the front. So if you can skip some steps, that's fine. I'm just going to try to show every step here so you can be familiar with that. So now we'll bring the 3 out front. And all right, so this is probably about as simplified as I can get it. I have two terms here. Now we're ready to actually take the derivative. So we're going to take the derivative next. So let's say f prime of x is going to be, I'm just going to bring this 1/2 out front. And now let's take the derivative of this term. So that's just going to be 1 over 6x minus 1 times the derivative of what's in the parenthesis, right? And then we'll do the same thing over here. We'll pull our 3 out front, and now we're going to take the derivative of the natural log of 1 over 4x plus 5 times the derivative of what's in that parenthesis. Okay, so I'll bring down my 1/2. I'm going to bring down 1 over 6x minus 1. What is the derivative of this term? Just a 6. Good. Now let's on this side, let's bring down what we have and evaluate the derivative here, which would give us a 4. Now let's simplify this. In the numerator we have a 6. If we divide it by the 2 in the denominator, then we would just get 3 over 6x minus 1. And then over there we would have 12, 3 times 4 in the numerator. Okay, this is a solution, but we're going to get a common denominator and add like terms to simplify this into one term. So I'm just going to pause it and do that work to the side. You can check your answers. Okay, so algebraically, if we got a common denominator, added like terms, and rewrote it as a single term, we would have this value. So you can check your work on this. This is the algebra. So if this does not appear in your textbook answer, then you may want to do this next step. Okay, this next one we're just going to talk our way through. It's similar to the other one. The first thing I'm going to do is just rewrite the problem. So this cubed root I'm going to rewrite as the 1/3 power so that I can use my property of bringing my power to the front. So that's where we are here. So y equals 1/3 the natural log. Now this is division. So how can you rewrite division? Using subtraction. Good. So now I've just simplified. We have the 1/3 out front, and then I rewrote those using subtraction. So my first step of taking the derivative actually starts here. all of the other steps we're using our properties to simplify. So we take the natural log of x squared minus 1 is 1 over x squared minus 1 times the derivative of the parenthesis minus 1 over x squared plus 1 times the derivative of what's in the parenthesis. And then so the derivative of this is 2x, so that's what's on top. The derivative of this is 2x. We factor out a 2 right here. So because the numerator has a 2 and this numerator has a 2, I pulled the 2x out front. And we just have this in parentheses so that the algebra is easy to simplify. Right here, just like previous, we got a common denominator. Add like terms here, so your x squared term cancels this x squared term once that negative is distributed. And we just simplify to a 2. Then we can multiply 2 times 2 to get a 4x and bring this all back together. So the gist of this is basically using our properties through these steps to get as simplified as possible so that when we take the derivative, it's going to be much easier to work with.